Hi, my name is Ângelo. I'm from Cruzeiro do Sul University from Brazil, and my paper is applying Agile software engineering to develop computational thinking children. This is a study of me, Ângelo, and Ismar Silveira. Introduction. Computational thinking can improve problem-solving skills on children. And system engineering is an important practice of computational thinking. Also, agile software engineering values in practice can add to the teaching of computational thinking and system design. In addition to that, we have the maker culture. The maker culture can be easily integrated with agile software engineering. So, we propose a conceptual framework for applying agile software engineering practice to teach children about computational thinking, especially in the system development perspective. Computational thinking and system design. Computational thinking has a lot to add to children's analytical abilities. Computational thinking is thinking to solve problems, automate systems, or turn data by constructing models and representations. So computational thinking involves, among other things, engineering thinking once computational thinkers build a system that interact with the real world. So when we are design a system, we are using computational thinking skills. We are learning about how to solve problems. Therefore, computational thinking is closely related to system engineering. Agile software engineering. Agile methods include features which are directly related to computational thinking and education. So some of the values in practice of agile methods are directly related to computational thinking education. And some of them are simplicity, collective work. So in education we have the cooperative learning, so it's related to that. This working software, so the focus is on the software working and not in the documentation of the software documentation. And it's motivation based. So education is also about motivation. The agile software engineering life cycle is very interesting to be applied because it's a process that employs incremental iterative development. In agile project, the software is produced incrementally, following a spiral life cycle. So the system grows gradually in repeating short stages. So think about that. This life cycle could be mapped into the learning life cycle. So to education life cycle, especially learning about computational thinking. Maker culture. The maker culture result can be used as a teaching strategy. Values of maker movement manifesto as make, share, learn, play, support, and practice, participate represent a great support to education. So the maker culture is also an interesting element to add to computational thinking education because children learn building things. So here we have our approach. We propose this life cycle and we propose these stages of development. So first we have here the planning stage, the first stage. So it's also incremental life cycle. And so the first stage of planning is about to plan a system with students. So here especially we talk about design games, the digital games as system to be developed, to be engineered. So children will be designing games, will be developing games at our approach. So the planning, the children will plan a game that they want to develop during the classes. So they will propose a game, and the teacher will help students um, to propose this game, and so to keep the expectations about the game. So the next stage is hands-on. The hands-on stage is about to teach students about the concepts that they will use to program the game, and about the design aspects of the game. And also we have the backlog. The backlog is about to get the game and broke the game into features, into requirements, and each requirement will be developed in the next stage, that is the pair programming. Pair programming is based a two-stage step. The first is about it's a program, a small feature, and test. So students will basically program and test, performing the pair programming. So the next stage is a reflection meeting. It's a really fast meeting where students will reflect about how the project is going, the process, the design of the game, the group, the cooperation, the group, if it's happening or not, the relationship with each other. So students will reflect about this. So we start the process. When we have something close to a product, so we start the sixth stage, that's play. So student must play with the game. They must have fun with the game that they build. So it's very interesting to children. It's a way to motivate students. And so have the next stage, spread the word. So students will talk about with other students about their game that they implement. They will present it to other students, to teachers, in the school, to his parents, to his family, and so on. And the last stage is share. So share the game that design on the internet, on the database, and things like that. The game development workshop. So we apply a game development workshop with this approach. We applied to middle school students from public institutions in Brazil. 4 teams were formed, and each team consists of 2 to 4 members. Each class spent about 1 hour and took place weekly, occurring from May to October. And there were around 20 classes per team. The projects were shared on a Scratch project database. Some team members present their projects at a regional science and technology event here in Brazil. So they present to a public. During the presentation, spectators were invited to interact with the games, and it was very motivated to students. In the final classes, students designed their own controls for the games using the Make. That I talk about here. Make is a device that allow students to design their own controls, with tangible things. So with some materials, they can design their own controls. So it's related to the maker culture also. So this is some pictures from the game workshop. Here we have 2 students interacting and design. So the control with make the programming of the game. And here's the control that they they are designing. And here we have a game that the students develop. These students develop. It's basically a platform game, and we have a ninja that they fight against zombies. Data collection and analysis. First, we have two tools of data collection analysis. First, we applied a rubric guided interview, and second, we analyzed the developed games, analyzed the requirements that were implemented. First, the rubric was employed so that students could self-evaluate their performance during the framework activities. Also, when the students would answer the rubric, the students were encouraged to talk freely about their experience in the different aspects of the activity. So here we have the rubric, and so we have 4 dimensions of our approach of the project development. So first is collaboration. After we have product design, programming, and process. And each of these aspects we have 4 stages. So beginning, development, proficient, exceptional. So from poor to rich, to a rich learning. It's a rich score. So we make a score for each progression level. So when student choose beginning, we scored less 2. So developing less 1, proficient +1, and exceptional +2. And we have calculated this sum of these scores. And here we have a table showing the points presented for each team. It was made individually, but we join all the results, all the scores given by the students, and the M is a mean. So as we can see, each of the dimensions receive a good score on the table. So we have received good scores with this approach. So the interviews, students express interest in the workshop and highlight their willingness to learn about game development. Here we have some highlighted subjects. The names are fictitious to not expose the students, but you have some subjects that were highlighted during the interviews. For example, Carlos said that he discovered about the career in game development. Bruna thinks that she can make a simple game by herself, and we have other things here. One thing that I forgot to talk about is about the game platform that we use, the game environment, the development environment. So we'll talk about now. The students work with Scratch, the creation environment Scratch. Why we choose Scratch? Because it's easy to use and is use visual programming, and students can learn it without many. It's not hard to learn. So students, it's very popular among the computational thinking research community, because students can implement something very productively. Okay, so let's back to the results. Sorry for that. We also analyzed the development games, and we define some basic requirements that are elements that make the game playable. So first, for example, F1, character movement, F2, perform an attack, F3, be defeated. So we have some features, some requirements that are based to the games. And so we have also additional elements that are make a score table, make a score, just a score, sorry. Um, additional implement additional movements to the characters, and they want more challenge, for example. And so here we have a table with the results of the games developed by the teams. So we have here the notation that C is complete, the feature was completed. P it's partially developed, and N not developed. And so, as you can see on this table, is that all the teams developed the basic features. The basic requirements were implemented by all the teams. And the team 3 completed all the features. And all the teams also have more than 60% of the requirements implemented, as you can see in the table. Conclusions. So the results pointed out that the learners felt involved in the aspect of the project, design, programming, process, and collaboration. The interviews revealed that the development of digital games was a significant motivational factor, and an analysis of the implemented games showed that students were able to build minimally playable products. As a future work, we want to apply to perform this approach on a college class, maybe on an information technology course like computer science or information systems, things like that. Here are some references. Any questions I will have to answer in the comments. Thank you.